Hi everybody and welcome to this workshop at the Think Virtual Conference. I'm Itziar de la Torre from IMST, and here I will give you an overview about the LoRaWAN certification and how to use the LCTT pretesting tool. The main goal of this workshop is that you gain some knowledge about the LoRaWAN certification, like what it is, why you should certify your product, what kind of devices can be certified, and the steps you need to follow to get your product LoRaWAN certified. Additionally, I will show you what the LCTT pretesting tool is and how you could get it. At the end, you will see a demo showing how to connect our IMST Lite Gateway to it and how to get the LCTT pretesting tool running on your computer. A LoRaWAN system is based on three main components: an end device, a gateway, and a server, where the main role of the gateway is to forward the messages exchanged between the end devices and the LoRaWAN server. Basically, the end device can be classified in three possible classes. Class A, where after each transmission of the end device, two receive windows are opened to allow a possible downlink from the LoRaWAN server. A Class B device is compatible with Class A, with additional receive windows controlled by beacons sent by the LoRaWAN network. And a Class C device is also compatible with Class A, where the end device is configured as continually listening as often as possible. Before a communication between the end device and the server can be started, the end device needs to be activated. For this, there are two options: activation by personalization or over the air. After a successful activation, the end device will be configured with an address and a network and an application session key. Now the end device is ready for a communication, and unconfirmed or confirmed messages can be exchanged with the LoRaWAN server. Let's start with the LoRaWAN certification. This is a program that checks that the end device has been implemented compliant with the LoRaWAN specification and ensure its correct behavior. And why should an end device be certified? Within the LoRaWAN certification, we also try to ensure the interoperability of the end device with any LoRaWAN network. After a successful result, the end device could carry the LoRaWAN certified mark and will be included in the LoRa Alliance promotional marketing. This is valid for LoRa Alliance members or certification affiliates. Here, it's important to remark that the LoRaWAN certification is only valid for the end devices. Currently, Class A devices following the LoRaWAN version 1.02 can be certified. The official certification is valid for regions of Europe, North America, Asia, Korea, and India. One common question at this point is: can a LoRa gateway get the LoRaWAN certification? No, currently the LoRaWAN certification is only valid for Class A devices following the LoRaWAN version 1.02. And which steps should be followed to obtain a LoRaWAN certification? First of all, you should contact the LoRa Alliance authorized test house. They will send you a quote and the questionnaire that you need to complete with the information of your end device. Once you have your product ready, you have to send it to the test house. It's important that, additional to the standard LoRaWAN application, the end device follows the end device certification requirement document, which I will explain to you in the next slide. The end device should be configured to be automatically LoRaWAN activated after switching it on to be able to run the test. The test house will run the test in an anechoic chamber and will share with you and with the LoRa Alliance the successful results. Congratulations! You will get your certificate and your product will be included in the LoRaWAN showcase of the LoRa Alliance. This contains some identifications of your device, like model, firmware and hardware version, as well as the information related to the LoRaWAN certification, like the version of the LoRaWAN specification and the regional parameters document used. Going into detail on the end-device certification requirement, the end device should include a test application running on port 224 to be able to run the LoRaWAN certification test. This includes several test commands for the test mode activation, deactivation, echo command, and selection of confirmed or unconfirmed uplinks. When the test mode is activated, the end device shall disable the duty cycle restrictions and send an uplink as quickly as possible, for example every 5 seconds. The uplinks should include as payload a downlink counter, which is incremented with every downlink received by the test application layer. Thanks to this test application, the test hardener can run several tests to ensure the correct LoRaWAN behavior. This includes the LoRaWAN activation, payload encryption, uplink and downlink frame counter, confirm and unconfirmed message exchange, the MEC command, and a kind of packet error rate test in both received windows for all the supported data rates. The first question to answer if you are willing to get the LoRaWAN certification for your product is, whom should I contact? You should contact an authorized test house and it will send you the required information and documents. If you have finished the design of your product and you are interested in getting it through the LoRaWAN certification process, the LCTT pretesting tool may be an interesting option for you. The LCTT is the pretesting tool developed by the LoRa Alliance to allow an easier pretesting of the devices before sending them for the formal LoRaWAN certification. Using this, the device manufacturers can save time and money, helping them to debug and finalize the design of their product. Everything you need to run the LCTT tool is a computer, a LoRaWAN gateway, and your end device. If you have interest in trying the LCTT pretesting tool, you shall contact the LoRa Alliance. The tool is available under the members portal and you will get a free license. Additional licenses have an extra cost of $2,000. If you are not a LoRa Alliance member yet, you could join the new certification affiliate program. This has a cost of $10,000 per year and includes also a free license for the LCTT. Additional licenses have an extra cost. In this case, your product could also get an official LoRaWAN certificate and will be included in the LoRaWAN showcase after a fee of $1,000. If you would like to try the LCTT pretesting tool, the question that probably comes up again to your mind is, whom should I contact? You should contact the LoRa Alliance to get access to the tool and the corresponding license. Once you have your end device ready and the LCTT installed on your computer, you should configure the LoRaWAN gateway. If you choose our IMST Lite Gateway, I will recommend you to follow our quick start guide, but basically everything you need is to connect it to your computer with an Ethernet cable and start an SSH client for its configuration. You will need to run the LoRa packet forwarder available in GitHub and also pre-install on the gateway image. And the settings in the global config file should be modified for your setup. As server address, you should enter the IP address of the computer where the LCTT is running. And remember the server UDP ports configured here because you should enter the same values in the LCTT. Finally, you should configure the different reception channels on the gateway. This will be based on the two center frequencies and 8 different channels with bandwidth 125, one additional channel on bandwidth 250, for example for spreading factor 7, and one additional channel for FSK. This setting must include at least the default channels as defined in the regional parameters document. Now you only need to run the packet forwarder application and configure the LCTT tool as follows. If this is the first time you run the LCTT tool, you should upgrade the license for its technology package installed. You will get the license file after sending the file generated by request license file to the LoRa Alliance. Then we will start creating a new project. The first step after loading this project is to assign a device. For this, we will create a new dude and introduce its information, and add a sample to it, also with its corresponding information. We will assign this dude to the project. Now we should configure all the required parameters. Under Dude Setup Editor, we will select the LoRaWAN region. For example, we will choose Europe in this demo. And continue the settings in the Europe tab. We should set to true that the device implements the certification requirements document. This means that it includes the test application. Select the Class A option and select the supported feature. For example, adaptive data rate, a block of link IDR request make command, TL channel request make command, data rate decay implementation, over-the-air activation, and support of trigger of a change request. Under Dude Extra Setup Editor, we go to the Europe tab and enter the Dude activation parameters. In this case, we will choose the over-the-air activation, and therefore we will skip the first 3 parameters for activation by personalization. We will start configuring the application UI and the maximum and minimum transmission power. Then we need to enter the address to be assigned after the activation and the application key and the device UI. Under the General Parameters Editor, the default parameters for each region are specified. Here, it is important to configure the gateway information correctly: IP address, model, and ports used for the communication with the gateway. Additionally, the IP address corresponding to the computer where the LCTT is running should be introduced as network server IP address. Under the Test Cases option, the test cases to be run should be chosen. Here, all applicable test cases should be selected if you want to run the complete LoRaWAN certification. But for this demo, we will run only the encryption test case after the device activation. Now we have everything ready to start our test. The first two data ensure that the communication with the gateway works properly, and the end device can start with the over-the-air activation procedure. All LoRaWAN messages sent by the dude and LCTT will be shown in the trace window. The LCTT will enable the test mode on the end device after its successful activation, and will make use of the test mode command to run all selected test cases sequentially. Finally, the test mode will be deactivated. You will be able to see the result of its test case after their completion. Once the test has finished, we will have access to the detailed log file. This will include a report with the final result and some additional information related to the LCTT version that has been used. Here you will also find the content of all LoRaWAN messages exchanged, including the radiation parameters used, like frequency and data rate. This will help you to understand and analyze your issues if you find some. Another question you may have is, can my end device get the LoRaWAN certification with the successful results got from the LCTT tool? Note, the LCTT is a pretesting tool and you should contact an authorized test house once you have your product ready. Besides the LoRaWAN certification, additional testing may be interesting for you. Here I will show you an overview of some of them. First of all, in case your product is based on an already LoRaWAN certified module, you may request a LoRaWAN certification by similarity, which simplifies the LoRaWAN certification process. Additionally, the radiation performance testing will provide a full radiated power and a sensitivity figure of your devices. For this, you should also contact a LoRa Alliance authorized test house, which will give you more information about this. And don't forget that the regulatory testing is not part of the LoRaWAN certification process. This approval is required if you would like to release a new product to market. This can take place before, after, or at the same time with the LoRaWAN certification testing. If you still have some questions or you need further help, please contact us at IMST. We can offer you technical support in every phase of your development process, from feasibility study to prototyping and certification, or even all the way through to mass production. So I hope you enjoyed this workshop and thank you very much for your attention. Please contact us for further assistance.